So in previous video we have seen Ohm's law. So what is the statement of Ohm's law? Once again we'll revise it. At constant temperature, the potential difference between two terminals of the conductor or two ends of the conductor is directly proportional to the current flowing through it. So it's simple working in the circuit, or it simply mean that potential difference applied across the conductor is always proportional to current. Means if we increase potential by increasing uh, the batteries, by increasing the number of cells in the circuit, so definitely the current will also increase. So V is equal to I, so V is equal to Ri. So here R is a constant called as resistance, and in order to solve some numericals we can write current is equal to potential difference upon R. So numericals of Ohm's law we'll see in classroom itself. Now next point, resistance. Now resistance, as I said, the resistance, it is the property of conductor which opposes the flow of electrons through it or flow of charges through it. It is the basic property. So my dear student, it is a bit confusion between two words, resistance and resistor. Actually resistor is it is the device, and resistance, it is the property of that device which opposes the flow of current. And according to Ohm's law, resistance, here we can see, according to Ohm's law, resistance is inversely proportional to current. Means if resistance is there in the circuit and if we increase resistance, so definitely current will be less or current will decrease. So if you want to less current in the circuit, so simply we have to apply more resistance in the circuit. Got it? And the SI unit of resistance is Ohm, as it was invented by scientist Ohm. So if the potential, and how do we define 1 ohm definition? So here if you see, resistance is equal to potential difference upon current. So unit of resistance is ohm, unit of potential difference is volt, and unit of current is ampere. So here we can write 1 ohm is equal to 1 volt divided by 1 ampere. So in this way we can define 1 ohm resistance. So the when do we say the resistance is 1 ohm in the circuit? So if the potential difference around the two ends of the wire is 1 volt and the current flowing through the wire is 1 ampere, then the resistance of the wire is said to be 1 ohm. Because if potential difference is 1 and current is also 1, then definitely resistance will be 1 ohm only. So this is very easy, my dear student. So once again, resistance, it is the property of conductor which opposes the flow of current or electron through it. According to Ohm's law, resistance is always inversely proportional to the current at constant potential difference, and the SI unit of resistance is ohm. Next, now this is very important point, my dear student, because many times many numericals are used to come on this point, this concept, that is resistivity. So in the end result of this point is resistivity only. So we'll see the factors affects on the resistance. So my dear student, there are basically two very important factors. So nature of the material, temperature, these all things can affect also. But in our syllabus, there are two things are very important. Two things which can affect on resistance, which gives the immense importance in this topic. Okay. So here we can say, first, the resistance of the conductor is depends on length and it depends on area also. But here, if you see in detail, the resistance is directly proportional to length. इसका simple meaning है, it simply means that if you increase the length, the resistance of the wire will increase. Got it? And here the resistance is inversely proportional to the area of the cross section. Means if you increase the area, resistance will decrease. Okay, then it depends on the material. Definitely it depends on the material, which material we are using, and then it is directly proportional to the temperature of the material also. If you increase the temperature, resistance also will increase. Okay, so these two things, this 3 and 4, okay, this is general things. Okay, but the very important thing is length and area. So we have to remember mainly these two things. Resistance is directly proportional to length and resistance is inversely proportional to area. So here you have written resistance is directly proportional to length and resistance is inversely proportional to area. Okay, so here we have written in combined form, that is resistance is directly proportional to length and inversely proportional to area. So my dear students, I'll explain why this happens. Okay, so if you increase length, listen to very carefully, if you increase length of the wire, more length will give the more path, and more path provides more resistance. That's why the length, more length gives the more resistance. That's why length is directly proportional to resistance, or vice versa. Got it? Similarly, if you say the resistance is inversely proportional to area, why area is inversely proportional to resistance or vice versa? Because if you increase area, area will give the more number of free electrons, and more number of free electrons will give more current, and if current will increase, definitely according to Ohm's law, according to this formula, if current will increase, definitely resistance will going to, or resistance is going to decrease. Got it, my dear student? So resistance is directly proportional to length and it is inversely proportional to area. Remember this. So here we can write in combined form, R is proportional to length, that is directly proportional to length L, and inversely proportional to area A. So in order to remove this proportionality sign, we have to write one constant, and here one constant is called as rho. Okay, rho, it is called as resistivity, or it is also called as specific resistance. So rho is having two names, first resistivity and specific resistance. Okay, so here we got the two factors, two very important factors which can affect heavily on the resistance. First, length, which affects directly, that is if you increase the length, resistance will increase, and second, area, which affects inversely, that is if you increase the area, resistance will decrease by increasing the current. So one constant called as resistivity. So what is resistivity in this case? How do we define resistivity? So if you calculate resistivity, just concentrate on the screen. So how do we find the definition of resistivity? So from this formula, from, just concentrate on this formula, from this formula we can write rho, resistivity, rho is equal to this rho, this rho is equal to R, as it is LHS, into this A divided by this L will go at denominator, divided by L, and this is the definition of resistivity. So how do we define resistivity? Simply it is the formula of R into A divided by L. So we can define it is resistivity. How do we define resistivity? Concentrate. Resistivity, it is defined as, it is the amount of resistance, okay, per unit length into area of cross section. This is the first method. And secondly, we can define resistivity. It is defined as, this is a very simple definition. Second one is simple definition I am giving you. Resistivity, it is the resistance of wire of unit cross sectional area per unit length. So this is a definition of resistivity. That is, once again, resistivity, it is defined as resistance of wire of unit area of cross section per unit length. So SI unit of resistivity is ohm meter. How ohm meter comes? Because resistance measured in ohm, this area in meter square, and this length in again meter. So 1 meter square and meter will get cancelled, so SI unit will be ohm meter. So this is all about the resistivity or specific resistance. So here for information, I have given some values of the resistivity for some insulators and conductors. So here if you see, there is huge difference between the values of resistivity in conductors and insulators. So here if you see, for conductors like metals and alloys have low resistivity. They are having very low resistivity because current conduction ability is very high, that is conductivity is very high. If resistivity is less, it directly means that conductivity is very high. So 10 raised to minus 8 ohm meter to 10 raised to minus 6 ohm meter, this is a range of some conductors, that is, this is a range of resistivity of some conductors. And if you see, if you see some insulators like rubber, glass. The range is 10 raised to 12 ohm meter to 10 raised to 17 ohm meter. This is a huge value of resistance because, or resistivity, because insulator basically they don't have free electrons. That's why resistivity is high. Clear? So third, the substance with low resistivity are better conductors often. Okay, that is better conductor of electricity than those with high resistivity, as I explained. So more the resistivity, less the conductivity of the substance. This is the importance of this. Then next point, this is very important, my dear student, resistors in series. This is, as we know, resistor which opposes the flow of current, or resistance, it is a property of material which opposes the flow of current. So if what happens if you connect the number of resistors in the series, okay, or number of resistance in the circuit. Okay, so here consider three resistors, R1, resistor R2 and resistor R3. All three are connected in series. So this combination, one after one, the connection of resistor one after one is called as series combination, because here first terminal is connected to resistance, then second of R1 is connected to first of R1, and this, then second to first of R3. So one after one combination is called a series combination. So there are some basic things which I want to mention. My dear student, if you connect resistors or resistances in series, so as they are connected, listen it very carefully, as they are connected in series means across same path. Okay, so in series combination of resistance, path is same, so current is always constant. Current is always constant means whatever current is there in R1, same current will be getting in R2 and same current will be getting in R3. But yes, at the same time, as they are connected in series, the potential difference in each of the resistance is different. Means V1 is potential difference across R1, V2 is potential difference across R2, and V3 is potential difference across R3. So V is the total potential difference across R1, R2 and R3. So here V we can write V1 plus V2 plus V3, because this V is addition of all these three. Okay, and this all arrangement is connected across one battery, key and ammeter to measure the current. So here ammeter will measure the current and voltmeter will measure the potential difference. Okay, so here when three resistors R1, R2 and R3 are connected in series across AB, the current in all resistor is same. The total voltage across the resistor is equal to the sum of the voltage across the each resistor, as I said. So this V is equal to resistance voltage across all, that is V1 plus V2 plus V3. So from this, my dear students, remember this, from this we can say that total resistance in this series combination, that is equivalent resistance or total resistance, we can say, is always equal to sum of the resistances of each resistor. Okay, means if you want to find the total resistance in the series combination of resistances, then simply we have to add all three resistances. So we'll get total resistance or equivalent resistance in series combination. So my dear student, here the basic thing is that if you connect resistors in series, so simply if you want to find the total resistance in the circuit, so simply we have to add all three or all resistance connected in series. So here RS represents resistances connected in series, that is R represents equivalent resistor and S represents series combination of resistances. So is equal to R1 plus R2 plus R3. So this is all about the resistors in series. So in this part of video we have seen Ohm's law, that is V is equal to IR. So V is potential difference, R resistance and I current. Okay, then we have seen in detail what is resistance. So resistance, here we got very important thing, resistance is inversely proportional to current and the SI unit of resistance is ohm. Then here we learn the factors which affect on the resistance, that is first very important factors affect length. If you increase length, resistance will increase, and second factor is area. If you increase area, resistance will decrease. And the definition of resistivity, that is resistance of wire of unit cross section area per unit length.